When we hear the word robot, we picture silicon chips, miles of wire, and complex algorithms. We assume autonomous machines are a modern achievement, impossible to build without electricity. But long before the first circuit board was printed, engineers were building machines that could operate themselves. In the 9th century, the city of Baghdad was the intellectual capital of the Abbasid Caliphate. The empire had established the House of Wisdom, an immense academy where scholars from across the known world gathered to translate, study, and expand upon the sum of human knowledge. Among these scholars were the Banu Musa brothers, Muhammad, Ahmad, and Hassan. Their father had been a notorious highway bandit on the desert frontier before abandoning crime to become an astronomer. When he died, the caliph took the 3 orphaned brothers under his wing, giving them the finest education available. The brothers mastered mathematics and geometry, but their true passion lay in mechanics. They began to look past static tools that required constant human effort, designing devices that could regulate their own behavior. Their work began with a royal mandate. The caliph tasked the brothers with recovering and translating ancient Greek engineering texts, including the works of early inventors like Hero of Alexandria. This diagram illustrates the basic principle of those early Greek designs. A basin of water empties into a lower container, creating a simple gravity-fed illusion. It is a linear action. Once the water runs out, the machine stops entirely, and a human operator has to manually carry the water back to the top to reset the system. The Banu Musa set out to bypass this physical limit. Their goal was to build systems that could read their own states and adjust accordingly, removing the need for human intervention. In the year 850, the brothers published the results of their research in a text called the Kitab al-Hiyal, or the Book of Ingenious Devices. It contained over 100 highly detailed schematics for mechanical devices. Many of these designs functioned as elaborate palace entertainment. The text describes a haunted bottle with 2 separate spouts. You could pour water into one side and juice into the other, and the vessel would pour them back out independently, never allowing the liquids to mix inside the chamber. Another design, dubbed the Moody Jug, actively refused to dispense its contents unless the user tilted it at a very specific angle or applied the exact right amount of pressure. To observers in the caliph's court, these objects seemed enchanted. The brothers, however, were utilizing complex principles of pneumatics and hydrostatics to disguise invisible physical forces as parlor games. We can see exactly how they accomplished this by looking inside their design for an environmentally friendly jar, essentially an automated public sink that dispensed a measured amount of water before shutting itself off. Looking at this cross-section of the vessel, the key mechanism is a conical valve. As the water level rises inside the lower chamber, the fluid physically pushes the cone upward into a fitted socket. This action completely blocks the flow of water from above. When a user drains water from the basin, the hydrostatic pressure holding the valve in place drops. The cone falls, the seal breaks, and the water autonomously resumes flowing to refill the basin. In modern engineering terms, this mechanism is called a feedback controller. The machine produces an output, in this case water, and then uses that same output to physically trigger its next action. By harnessing these subtle variations in air and water pressure, the Banu Musa created true automatic fail-safe systems. The brothers applied these principles to even more complex tasks. They designed a fully automatic mechanical flute player, as well as a hydro-powered organ that could play music on its own. The music was driven by the mechanism we see here, a continuously rotating cylinder studded with raised metal pins. As the cylinder turns, the pins strike specific internal levers that release hot steam or air to play the notes. The genius of the design was its modularity. If you wanted to hear a different song, you didn't have to build a new instrument. You simply removed the cylinder and inserted a different one with a new arrangement of pins. The Banu Musa successfully separated the physical hardware of the machine from the instructions telling it what to do. In doing so, they created the earliest known programmable machine in human history. The Banu Musa were serious civic engineers. As their understanding of mechanical control grew, they directed their attention toward demanding industrial problems. They invented the clamshell grab, an automated mechanical claw. It allowed engineers to easily extract heavy debris and valuable materials from the bottoms of riverbeds, an incredibly difficult task at the time. For deep excavations, they designed specialized mechanical bellows that continuously pumped foul air out of wells and mines. They even developed early gas masks to protect the laborers working in those toxic environments. The exact same physical principles used to pour party drinks and play mechanical flutes were scaled up to handle heavy-duty physical labor. 3 centuries later, another master engineer named al-Jazari studied the Banu Musa's manuscripts. He adopted their automated valves and cylinders, adding his own invention, the crankshaft, to build elaborate water-raising machines. Eventually, the Book of Ingenious Devices circulated across the Mediterranean. The concepts of the conical valve, the float chamber, and the feedback loop permeated European engineering. These mechanisms became vital components of the Industrial Revolution, used to regulate pressure in massive steam engine boilers. Even today, the simple float valve sitting in the tank of a modern flush toilet relies on the exact same mechanics the brothers mapped out. The logic driving our automated world was not first written in silicon. It was authored with water, air pressure, and bronze in the heart of 9th century Baghdad.